Hello everyone, welcome to Gora Studies. In this video, I am going to discuss about prototype design pattern. So what is prototype design pattern? This is also one of the creational design pattern, and this pattern basically says that cloning of an existing object instead of creating a new one. Okay, so when we need to use this prototype design pattern? Basically when creating a new object is much expensive, then we need to go for the prototype design pattern, because in this design pattern we are not creating the same object from the scratch, we are just cloning the object. So suppose you have one object, you created one object. Okay, so here you can see, suppose you have one class. Okay, so this one is your object one that you created and executed. Okay, you created from scratch this one, all the the logic and everything is they executed, and that object created. Okay, now you required another two objects. Okay, from the same class, object 2 and object 3. So suppose object 1 basically contains the some of the network connection or the database connection. You are fetching some user information using some REST API, so that you have to create a network connection there, or else you just getting the data from database. So all the connection is already established in this object 1. Okay, so if you want to create the same object again from the scratch, then all the operations should be the perform here also. Okay, so in that case it will also take that much of time. Suppose this object creation time is, I'm taking, let's say 30, uh, the what I can say, around 30 second, or maybe 10 second. 30 second is almost, it's a very high, 10 second. So that 10 second is also required for object 2 if we create that object from scratch, and then the same time is also required for object 3. Okay, but if we create the object once, the object one time, and just we clone this object, then that much of time will not required, because to create this object 2 we don't require that much of time, the 10, the whatever this uh, second. Okay, or 10 millisecond, whatever. Okay, so that much of time is not required. Okay, we can save that much of time to create the object 2. Okay, even for the object 3 also, if we clone that object. Okay, if we clone that object, then so if we if we can save that much of time to create the object 2 and object 3, then it will increase the performance of our application. Okay, so basically this is the reason why we need to use the the prototype design pattern. Okay, when we have the creating new object is much expensive, it will take, when the creation of new object will take the much time, then we are not creating the object from scratch, just we are cloning the object. Okay, from the first object that we created the first time. Okay, so that is basically the concept behind this. So what all are the advantage? You can see here that the first one already discussed, that this pattern save the cost of the object creation and also save the time. Correct. The second, it reduces the need of subclassing. Okay, so in that case, if you cloning the object, then you don't need to create the the subclasses. Okay, it hides complexities of creating objects, right? The whatever the complexities, whatever the the logic needs to be executed, everything is done here in the object one. When the object one is getting created, then this this class, this basically class getting executed, and this object is getting created. Correct. So if you clone clone this object 2 and object 3. Okay, by cloning, if you create this object 1, object 2 and object 3, then we don't need to perform all the logic and everything. So in that case we hide complexities of creating objects. Okay, add or remove objects at runtime. So as we are cloning the object, the from object 1, so what the compilation is done for this object 1 only. So for object 2 and object 3 you don't require the compilation again, so we can the add and remove the object at the runtime. Okay, correct. So you understand all the advantages here, correct? Okay. Okay, let's understand this concept through coding. So this is my IntelliJ. Under prototype folder I am creating one class. Just I am giving the name of the class is user, correct? Okay, I am now taking one field inside that, uh, that is private string user information, right? Correct. So let's create the getter and setter for that. Done. Fine. And let's take a public method here, get user data. Okay, so inside this method, okay, you are just making the whatever. If you are getting the data from the third party, so you can write, you can establish the network connection and establish network connection and fetch data using rest call or else what you can do here, uh, establish a database connection and fetch the data from database. Okay, so this two the operation are costly, because we need to establish the network connection to or HTTP connection, that is we need to make a REST call, or to fetch the data from database we have to make an database connection here. Okay, suppose this whole things is taking 5 second. Okay, 5 second, whole things is taking 5 second. Okay, so if you create this, create the the object from this scratch, okay, all the object from this scratch, then every time when you are creating, first time when you are creating the object 1, then also when this method will be executed it will take 5 seconds. For object 2 also it will take 5 seconds. For object 3 it will take 5 seconds. Maybe if your code is much complicated, then it should be take more than 5 seconds, maybe 10, 20 or 30 seconds, okay, based on the complexity and network bandwidth and everything. Okay, so now we are doing something like this dot user information. I'm giving some string data, the user data from database. Okay, just I need to print that the message that I'm giving there. Okay, now this is mainly the user class. Okay, so what all the the operation you need to perform, what all the logic you need to write, you are writing here, and that will take 5 to 20 or 30 seconds. Okay, this this section this section of code, okay, basically taking the time to execute. Okay, now let me create a main class. I'm giving name of the main class is user main. Okay, let me take the main method here, and I'm creating the object of this class. Okay, user class, user is equal to new, the default constructor is there, so by using that constructor we can call this user dot get user data. We can print system dot out. Okay, we can print the user. Okay, so here you can see I'm running this program. Okay, okay, let me, it is printing the object. Okay, let me override the toString method so that you can see the string, the format of this object. So let me override the toString method, toString. Okay, not override. Let me do where I am doing it. Okay, here. Okay, let me generate the toString method. That would be better here. Okay, toString, correct. So you can see that it's returning the user information and the string value what I given there. Okay, now let me run this class again. Let me clear the console and run this class. Yes, so here you can see it's printing the information. Okay, this is the user one. Let me create another object. Okay, another object for that. So that user one and then new. So what will happen in that case if we do like that? Okay, in that case also, when we are creating this object, correct, then this class, okay, is compiled and executing. Okay, this class being executed here, all the code. Again, I am telling this section, okay, we need to write the business logic, and that will take the, the the maximum number of time to execute the logic and everything. So the first time when we are creating the user object, okay, then also the whole class will be, executed. And second time when we will create this object user one, then also, this class will be executed from the scratch. So the same time will take whatever the time will take to, the execute the user, this one, the class user class at the time of creating this creation of this object user object. Okay, then so the same time will take here also, okay, to create the user one object also. So in that case we need to use the prototype design pattern so that, the time we can save the time, whatever the time, required here to create the user one object. Okay, so if you do like this, okay, uh, not creating the object from scratch, just we need to clone that object. Okay, this is the object already we created, and just we are cloning that object. Okay, cloning that. Okay, now the problem is here that the clone method is not accessible here for the for this object. Okay, so go to this class, the user class. Okay, so what we need to do here, we need to make this user class as clonable so that we can access the clone method, okay, of this class. So for that, what we need to do, we need to implement the clonable interface. Okay, clonable interface, what is that? Clonable is a marker interface. Okay, I think you know, but yes, let me give a brief idea on this, what is the marker interface. Okay, basically the marker interface is an empty interface. It means the marker interface does not have any method, any fields, any constant. Okay, it's an empty interface. So what is the use of this interface? This interface is basically marking this class and the object, okay, as a, the clonable or clonable, so that the compiler or JVM can understand that, okay, this object is a clonable object. Okay, so, or you can say it's a, some of the time we can say it's a, you know uh, tag interface also. It's tagging the class and the object, okay, as a clonable. Similar like clonable, we have the serializable also. Okay, so by using the serializable, we can make any class, or we can just inform to the JVM and compiler, Java compiler, that okay, this class is serializable, or in that case it's a clonable. So by to use the clonable interface, basically this marker interface just informing to the JVM and the Java compiler, so that they can understand, okay, this class is, and this class is a um, you know uh, clonable class. Okay, clonable object. Okay, fine. So if you go to this clonable class, you can see there is no method, no fields, no constant. So it's an empty interface. You can see it's an empty interface. Okay, and it is called what? It is called marker interface. Okay, so if you need, I will create a separate video on this marker interface in detail. Okay, okay, fine. Now we we are making this class as clonable. Now we are going to use this clone object, but again the clone object, sorry, this clone method, we need to access this method, but this clone method is not accessible. Why? Clone method is not available there in the user class. Clone method is basically available there in the topmost parent class. What is the topmost parent class? This is the object class. Okay, so this is the object class. So if you click on this object class, okay, you can see the clone method. So let me search. This is the clone method. Here you can see, here this is the clone method. It will return the type of object class. Okay, the object of this class, object class. Correct, this is the topmost parent class for every class. Okay, so this clone object is available there, and it is a protected. Okay, so as it is a protected, okay, and the object Java, this class package and our custom class package is not same. Okay, that's why the clone method is not accessible from this class. For that, what we need to do, we need to override that clone method. Okay, here, and then only we can access that, the clone method. Let me do that. If you go to override, generate override methods, so you can see the clone method. Okay, so just you can override this method, and it basically throws the clone not supported exception. Correct. Okay, now come here, and you can access. Now you can see this clone, the method is accessible. So here you can see some error because it's throwing the clone not supported exception. We need to throw that. But here user dot clone, this will return a type of object class here. But okay, but we need this user type of user class. Here you can see required type is user, type is user, and provided is object. So we need to typecast it. We need to typecast it. Okay, fine. Now the object, this object is also created. So user on object is also created. Now let me print that one. Okay, so same response you will get, same print you will get. Let me run it. Okay, so here you can see both the is coming, but you see, okay, so the information are coming printed here from both the object. Okay, but how we can understand that? Okay, the object one, the user object is getting the time, much time, but the user one is not getting much time. Okay, for that we need to use some thread concept. Go to here. Basically this code is taking, the time. This code is, suppose suppose we retain here the, the established connection establishment code. We need to establish the, the HTTP connection or database connection. That code we retain, so that will taking time. Okay, maybe it's a 5 second. So what we need to do here, we just put the thread in sleep mode for 5 seconds, so that you can understand. It will throws an exception. Okay, correct. Yes, let me add this. Fine. Accordingly, here also we need to use, we need to throw this exception also. Now you can see, let me do one thing. Let me print something here, so that you can understand. System dot out dot print ln. I'm giving here that prototype prototype design pattern. Okay, after printing this message, the, the user object will be created. Then the information will be printed from user object. Then we are cloning this user one object from user object, and it will also print the information from user one object. Now you can understand that. Okay, after printing this message, when this line will be executed, then okay then then, this method also will be executed. So when this method will be executed, then, we are just putting the thread in sleep mode for 5 seconds, because we are assuming that, okay, our logic and everything will take 5 seconds. Okay, so here you can see, after printing this message, okay, exactly after 5 seconds you can see the message from this object. But to print the message from user one object will not take 5 seconds. Maybe immediately the user one will, you know print the object, because all the execution is done in this object. Okay, in this object, when you create this user object, then all the execution is done there. So the object is already compiled and executed. So second time when we are cloning this object, then it's not required to compile. Okay, and also, it's not required any execution. Okay, now you can see clearly. Okay, let me run this. Okay, is printed. Now see, after 5 seconds you can see. Yes, after 5 seconds you just, okay, you see there that, okay, this line is printed here, and immediately after that it is also printed. It will not take the 5 second. Okay, it is not taking 5 second. The 5 second taking only this line, this message. Okay, so when the message is getting printed from a user object, then it is taking 5 seconds, because the object is compiled. Okay, execution, everything is done, compilation and execution, everything is done from scratch. Okay, so once the compilation is done, and once executed this object, the user object, then when we cloning the user one object from user object, okay, it is not required any compilation and execution. It's just taking the data from user one object and printing here. Okay, now you understood how, the prototype design pattern is working, correct? Okay, fine. So what is the use of prototype design pattern? When we need to use this prototype design pattern? Basically, when we need to instantiate an object, okay, at runtime, when we need to add or remove any object at runtime, that we need prototype design pattern. The second point is that when the creation of an object, okay, is much costly, okay, or when the creation of object will take much time, then we need to use the prototype design pattern. Okay, so I think you understood what is prototype design pattern, how prototype design pattern works, what's the advantage and usage. Okay, so that's it in this video. Thank you for watching. See you in the next video.